So we're asked to find the derivative of y with respect to x, and here is an equation. So to do that, we want to differentiate both sides with respect to x. So that gives us dy dx on the left side, the derivative of y with respect to x. And that equals the derivative of inverse sine with respect to x. And so it's kind of a complicated differentiation if you try to do it from scratch every time. What you can do is you can check out our textbook where they have a proof for y the derivative with respect to x of inverse sine is 1 over the square root of 1 minus x squared. Except in this case, our x is 1 over 9x plus 6. So when we apply the formula, we got to make sure we put 1 over 9x plus 6 everywhere where we see an x. So that's pretty yucky. That's being squared. But we're not done. This is where a lot of beginning calculus students would stop. But look, that's the derivative of the outermost function. The derivative of inverse sine is this. But what about a derivative of the innermost function? This is 1 over 9x plus 6. We need to multiply by the derivative of the innermost function. And so to do this, you could use the quotient rule, or you could rewrite it as a power. You could write this as 9x plus 6 to the negative first power. But if we use the quotient rule, it's the derivative of the numerator function. So it's the derivative of a constant times the denominator function kept the same, subtracted by the original numerator function times the derivative of the denominator function. So the derivative of 9x plus 6 is just 9. It's all over the denominator being squared. So this is negative 9 over 9x plus 6 being squared. So negative 9 over 9x plus 6 squared. Okay, can we clean that up? I don't honestly know off the top of my head because this is pretty crazy. So the numerator, 1 times negative 9, that's easy. That's just negative 9. The denominator, I see a 9x plus 6 I could potentially cancel out. Let me look and see what Newton has for their answer before I try to go off. I have an idea for how this could potentially be simplified. So again, we want the equation of the tangent line of to an inverse function. So we need that result that we derived. I don't remember if it was in this video or not. I'm jumping around when I make the videos. But we can get that by taking 1 and dividing it by the derivative of the original function with the inverse function plugged into it. Okay, so the derivative of the original function, that's a power function. That's something to the 1/2 power. So the 1/2 comes down and multiplies. And then it gets reduced by 1. So that's the same thing as 1 over 2 square roots of x minus 4. Because it's a negative 1/2 for a power. Okay, so now we know what the derivative of f is. We just need to plug the inverse into it. Let's see, so this is the derivative of f, but now instead of x, I'm going to plug the inverse of x into it. And so there's our notation. Now if they want this at the point 2, 8, that means they want 2 for x. So we're just plugging a 2 everywhere where we see an x. And we already know what this value is because we have a point. If you plug in 2 for x, you get out 8 for y in the inverse function because this is a point on the inverse function. This is 1 over 2 square roots of 8 minus 4. And so that's 8 minus 4 makes 2. Square root of 4. Sorry, 8 minus 4 is 4. Square root of 4 is 2. 2 times 2 makes 4. So this is 1/4. That's the slope of the tangent line, right? This is a derivative, so if we plug in a value into the derivative, it spits out a slope. We got 1/4 for our slope. So to find the y-intercept, we just plug in our point that we're given. 2 for x, 8 for y. So I'm just going to do that quickly. 1/4 times 2. Subtract 1/2 from both sides. So that's 16 over 2. So that's 17 over... No, wrong way. 15 over 2 for b. So this is y equals 1/4 x plus 15 over 2. Yeah, so in the denominator, we're going to use this idea that the square root of 2 times the square root of 3, you can multiply them because they're both inside a square root. We want to rewrite this so that's inside a square root. This is, we'll keep this the same. And then this is, I still haven't taken care of the denominator. I'm going to write it as the square root of 9x plus 6 to the 4th. A square root is a 1/2 power, so 1/2 on top of a 4, they would multiply. 1/2 times 4 makes 2. So this would turn back into what we have up here. I haven't broken any math rules because I'm able to reverse it and it comes out to be the same thing. But now they're both inside a square root, now I can multiply them. 9x plus 6 times 1, this is all still inside a square root, so 9x plus 6 to the 4th times 1 makes 9x plus 6 to the 4th. And then 9x plus 6 to the 4th times 1 over 9x plus 6 squared. Right? You could square the top and square the bottom. The 2 and the 4 will reduce. That's just going to give us 9x plus 6 to the 2nd power. So some tricky algebra going on there for sure. Now both those terms have something in common. You can factor out a 9x plus 6 from both of those. And it's 9x plus 6 squared that we can factor out of both of them. And then in parentheses, what's left over on the inside is 9x plus 6 to the 2nd minus 1. Right? I factored a 9x plus 6 squared out of both of these terms. And if you do that, you can reduce the radical. This is negative 9 over the square root of 9x plus 6 squared. A square root and a square cancel out. Makes just 9x plus 6. I think it would, yeah, no, because it's being squared. Yeah, and then here is going to be 9x inside the radical still. 9x plus 6 squared minus 1. Okay, so that is the same thing as what we had up here. I mean, go ahead and try to type this in Newton, but oftentimes it marks it wrong unless we do some simplifying. That's the fully simplified answer.